Good afternoon, everyone. So this is the last problem and doubt clearing class for the course name Symmetry, Stereochemistry and Application. The course instructor was Professor Umsuman Roy Choudhury, and I am Povin Maiti, teaching assistant of this course. So far in this course, we have learned about the identification of objects. That is the how we find out any chemicals or any molecules and how can we give the name. So the name of there will be some international community which are give the name of all the molecule, and there will be a standard rule for to get this name. So the international community was UPAC. So they are standardized to given a name. So like this molecule, how we give the name of this molecule. So to give a name of any molecule, we have to understand there will be some three part of this. So first part is a prefix. Prefix is called what substituent are added in this molecule. Then parents. So what are the main compound which belong, and last is the suffix mean the functional group what are present. So three part. The first is the called prefix or prefixes. The second part is the name is called parent, and third part is the names comes from which family or what functional group are present. So the suffixes identify the molecules, the family. The parent indicates the number of carbon atoms present, how much carbon atoms are present, and the molecule. And prefix identify what other substituents are present. Like in this molecule, so there will be one substituent present. So these are methyl. So nothing means, so this the carbon, and there will be three hydrogen are present. So this is the methyl group. So how we'll give the name? So the name will be start from here. So this will be 1, this will be 2, this will be 3, number 3, and this will be 4. So total 4 carbon. So it will for the butane, and the methyl is present here. So 3 methyl at 3 positions. So 3 methyl butane, and the for alcohol we are giving name that all. So 3 methyl butanol, or you can give the 3 methyl 1 butanol. Similarly, so UFAC name is the community give the International Union Pure Applied Chemistry, which is founded in 1999. So according to them, so I will give the name of this molecule. So this is the same, the 3 methyl. Now we have to find out the name of this molecule. So we have to find out the what are the substituent are present. So there will be substituent present like fluoro, and substituent like this, and this will be the main chain. So there will be substituent like the 2-fluoro, and in isopropyl there will be 3-methoxy group are present, and N isopropyl group, this one the isopropyl group, and this the N-methoxy methyl, and total 1, 2, 3, 4. 1, 2, 3, 4. So methoxymethyl, and total is the 5. So propan 1 amine. Next in this molecule, so there will be fluoro. So you have to find out that this molecule are E or Z. So E means the molecule will be in cis, Z means the molecule will be. We have to find out the highest priority is which side are present. So in between this fluorine and this one, so fluorine is highest priority. And here this one is the highest priority. This is the lowest priority. So the lowest priority are in the same side, the highest priority are same side. So this will be the jet, like cis conformation. So this molecule will be at 3 position, that will be fluoro group, 3 fluoro. At 7 position, there will be dimethyl. So starting from here, 1, 2, 3, 4, 6, 7. So at 7 position, there will be 2 dimethyl group. So 7 dimethyl, 3 fluoro. And total number of carbon is so octane. 3 at 3 position, there will be N. So 3N to 6. At 2 and 6 position, there will be ketone group. So 3N to 6 dione. Similarly, we have to first the name of the compound. Now we have to find out the symmetry of this molecule. So how we will find out the symmetry of a molecule? So if a molecule, symmetry means how that 3D this molecule look like, how we can identify the what this molecule are same or others. There will be C1, that is the after 360 degrees. So every molecule have C1. So after 360 rotation, every molecule have the same configuration. So this would be identity of the molecule. Any molecule have that C. Then the sigma. So if in a molecule only sigma plane are present, like sigma plane are present from this direction, so sigma plane are present. So this will be CS, and there will be inversion center present only. Then that will be CI. Then higher symmetry. So now we have to find out the principal axis. So our principal axis does have that. Does it have C2 axis or not? And this one, the normal molecule tetrahedral, octahedral, icosahedral, C infinity B, or cyanide, or carbon dioxide, the D infinity B are present. For the higher symmetries, so find out the principal axis. Then we have to find out that the principal axis is perpendicular to the CT axis. So if there will be more than one C2, or and then we have to find out if the principal axis is perpendicular to the CT axis. If yes, then the D group element. If no, then the C or S group element. Between C, if there will be sigma H planar present, so the name will be CNH. CN is come from the maximum principal axis what are present in the molecule. If there will be sigma B are present, then that will be CNB. If there will be no sigma planar present, so if there will be any improper rotation present like S2N, S, so S2N, and if there will be nothing present, no inversion, so only C are given. No sigma plane, no inversion, so only C. Axis of symmetry. For D group elements, similarly, if the principal does it have a principal axis and it is perpendicular to the C2 axis, then up to D. So if there will be sigma planar present, then name will be D, and N is the for the principal axis number. When sigma D, Dn, that if there will be any vertical or any sigma plane present, not sigma H, so then that will be D and D. And if there will be no sigma plane present, only D, so this will be D, Dn. Now, in the next we understand that conformation. About the conformation. Conformation means the how a molecule in the normal system. So the conformation will be two factors that what that destabilize the conformation. One is the steric interaction. Steric interaction means that if there will be bulky group are present, so they will be sterically hindered. So this will be steric crowding are present. So that will be destabilize our conformation. So there will be one is the steric interaction and another is the torsional. Torsional means if there will be angle. So like a sp2 is a perfect angle, sp3 have perfect angle. If there will be any angle are lower or anything, so there will be torsional distortion of parent. And stabilize the conformation. Stabilize the conformation, like if the conformation is anti-conformation. Anti-conformation means whether that more bulky group are present already anti to each other. This conformation will be more stable conformation. Then if we have to find out any hydrogen bonding or gauge type conformation are present in that molecule. And next we have to find out any electronegative element which due to present due to the gauge conformation. So this is an example where that a butanol molecule 1, 2, 3, 4. So in this molecule, you have to find out when those two methyl are in the same. So this will be the largest energy. So this will be the most destabilized and most stable configuration will be someone that the Gaussian interaction and the anti because the anti where the steric crowding are almost each other. And if there will be some electronegative group like this will be fluorine and this will be hydrogen like that. So then the Gaussian interaction will be more stable. And if there will be something like OH or H are present in that Gaussian type interaction, then there will be hydrogen bonding will be favor. So hydrogen bonding conformation will be more stable. So what are the torsional strain? So torsional strain, if there will be hydrogen in the eclipsed position, eclipsed means this position, eclipsed. So then the torsional is the 4. If there will be methyl and hydrogen, the torsional strain will be 6. If there will be methyl, the torsional strain is more. If there will be gauzy, the torsional is less than eclipsed conformation. We have to name the compound, and after that we have to find out that RS nomenclature. So for RS nomenclature, we have to identify the chiral center and numbering them at priority wise. What are the priority in? So this is a chiral center. Then we have to find out what are priority are present. So most highest priority is fluorine. Second highest priority is this one, and third. Now we have to find out how this molecular rotate. Is it clockwise rotation or anti-clockwise rotation? 1, 2, 3. The rotation is like this. So this is a clockwise rotation. So what should be the name of this? So what should be comparison? The comparison will be R. When lowest priority is below and the clockwise rotation, so this will be R. When the lowest priority is above and the clockwise rotation, then there will be S comparison. So I have given the point like this. If your first 3 priorities clockwise and your 4 priorities below the plane, so the comparison will be R. Similarly, if the opposite will be happens, the comparison will be S. And if your first 3 priorities clockwise, but the first priority is above, then that will be S comparison. Similarly, if the first 3 priorities anti-clockwise and 4 priorities below, then that will be R comparison. So the name will be R comparison. Now to draw that molecule. So if you first for priority horizontal comparison will be S. Your first 3 priority is clockwise and your 4 priority is horizontal like this. If 4 priority is horizontal, first 3 priority like 1, 2, 3 is clockwise, then that will be 1, 2, 3. Clockwise will be S comparison, anti-clockwise will be R comparison. So now this is the anti-clockwise direction. So this the comparison will be R. So if your first 3 priority is clockwise, a Fisher system, so the clockwise will be direction will be yes. Similarly, 3 priority clockwise and your 4 priority is the vertically placed. If this hydrogen will be here like this, anything fluorine. Hydrogen OH like this. So the most high priority is 1, 2, 3. Also clockwise direction and highest priority is below. So then this configuration will be R. Similarly, if your first 3 priority is clockwise and your 4 priority in the vertical, so the configuration will be yes. So if this anti-clockwise, if this will be anti-clockwise, then the configuration should be F. Next, we have to find out that symmetry of the element. So in a molecule, so if that molecule have improper axis, axis ACN, so then the molecule will be symmetric. And if there will be no improper axis, then the molecule will be dissymmetric. And if symmetric molecule, if there will be no axis of rotation, like any no axis of symmetry are present, then there will be asymmetric molecule. And asymmetric molecule are generally the chiral molecule. So this is the example where we have to find out that this molecule is symmetric, disymmetric, or asymmetric. So I have told that if there will be improper rotation, then this molecule will be symmetric. So like if I draw this molecule like this, and if I this molecule 180 degrees, so this will be like this, then will be rotation. Improper acceleration means rotation and reflection. After rotation and reflection, if you get the same molecule, so this will be same axis of symmetry. So here that 180 degree rotation, so this will be S2 axis of symmetry. So after rotation and reflection, we get this molecule which is similar to this molecule. So this molecule are symmetric molecule. So also their symmetric molecule are not chiral, but there will be this molecule are not chiral. Now we have to the next we have to find out that SN1 pathway, SN2 pathway. So SN1 pathway is that first SN1 pathway means where the carbocation are first generated, or SN2 are in between carbocation, the transition state where the one is coming and another is going like that. So in this we have to find out in the SN1 pathway which will be the most faster reaction which will be less. So if the SN1 pathway, so the carbocation will be generated, so methyl. So methyl is less stable, PHCH2 is the most stable carbocation, PHCME2. Again between PHCHME and PHCH2ME2. So we know that the radically wise 3 degree carbocation are most stable, 2 degree, and then next, then 1 degree. So if there will be, so this will be give the 3 degree carbocation. These are the for the benzylic. And this will be at 2 degree. 1 degree carbocation is less, so this reaction less favor than the benzylic, then the 2 degree, and then the 3 degree carbocation. Then with the next the aldol condensation reaction. The aldol reaction are two type, like acid catalyzed aldol reaction. So for the acid catalyst, first the acid from any HCl or anything. So first this acid H plus proton abstract by this carbonyl center. So now this carbonyl center on the OH, so then this hydrogen transfer its electron here and this OH remove out, so we are getting CH2. Even when it's come back its electron, this CH2 minus will attack another carbonyl center, and finally we got this molecule, and after removal of H plus, so we have got this molecule. Acid catalyst, we have to remember first the protonation happen in the carbonyl center, and for the base catalyst the proton abstract from the alpha position. So this will be our alpha position. So from alpha position the proton abstraction happen. So again when this carbonyl oxygen electronegative oxygen is come back, so again its attack will be the next carbonyl center, and again it become a from water it's take hydrogen and it becomes like this. Now we have Hofmann degradation. So Hofmann degradation is the very important reaction where that if we reduce that carbon chain, so then the Hofmann degradation will be helpful. So if you want to reduce the carbon chain, so there will be RCONH2 from that this carbonyl are reduced, so we are getting RNH2. How the reaction will be positive? So first alcohol, this will be OH. First this abstract from one proton from this nitrogen, so it become N minus, then this N minus attack on Br, so that N bromide are formed. Then this N bromide, another abstraction of proton from here, so we are getting N bromoamide anion. Then the transfer of this alkyl group in the N side, so we are getting isocyanate RNC double bond O. This, then again in presence of RNCO, so there will be water is present, so again attack on this here, so we are getting RNCOH, and it is come back the COH, so again removal of this carbon dioxide from here, so finally we are getting a primary amine. Mannich reaction where that in a carbonyl, the first the protonation happened in the carbonyl, then any that amine group attack on that carbonyl center, so when it will be attacked, so it will be water will be removed from here, so ultimately we are getting this. So again another carbonyl present, so RCOH, so this CH2 will be attacked here, so it will be become, so this will be CH2NET, and this will be attacked RCR double bond O, and this will be CH2. So after removal of this H plus, so it will become this. Also today's classes we have learned about that crystallography, how we give the name of this crystallography element, how we will identify what are the lattice and all of these things. So any confirmation if there will be like the confirmation area like this. So what will be your stable confirmation? So this will be stable comparison because there will be possible of hydrogen bonding. So for this, for any conformation, so you have to remember that stabilized conformation will be anti, and if there will be hydrogen bonding, that is the Gauss conformation. Hydrogen bonding are present, not Gauss. So and if there will be electronegative element are present, so then there will be Gauss conformation. I keep there again. So what we learned so far. So first we have known about the identification of any chemicals or any molecules. So how we can identify this? So there will be one community like UPAC which giving the identification of that molecule. So there will be a standard rule how we can identify of this molecule. This UPAC community was established in 1999. So according to them, so first to identify any molecule, we have to give the three prefix, parent and suffix. Prefix is that first substituent are present in the molecule. Parents is tell about that how much number of carbon atoms are attached to the molecule and how the long chain it is. And suffix will tell about that family name in which family it's belong, like that is the what functional groups are belong to that molecule. So there will be three part in every molecule. When we have to give that UPAC name of any molecule. So that three parts will be prefixes, parent and suffix. The suffix will be identified. So for this molecule, this which is the suffix. So it will be alcohol. So the suffix identify the family. So the name of this molecule will be at 3 position there will be methyl group are present. So this will be 3 methyl. Total number of carbon is butane. So 3 methyl butane and 1 position there will be OH. So 3 methyl butanol. From this we have to identify that chemical name of this molecule. Then we have to learn about the symmetry of a molecule. So symmetry of a molecule will tell us about that what are the symmetry elements are present in that molecule and how we can identify that this molecule are present or not. So you have to give if there will be more than one C2 will be present in a molecule that, and if If that there will be any principal axis which is the perpendicular to the principal axis, then in the symmetry element name the D will be coming, and if there will be no perpendicular relation to the principal axis, then the C will come. So, and any molecule, identity molecule, so any chiral molecule are, all molecules are identical because only T6 here the C1 means the rotation of the molecule 360 degree. So every molecule have that identity element like E. So C1 means 360 degree rotation, C2 means that 180 degree rotation, C3 means 360 divided by 100 degree rotation like that. An improper axis of rotation S2, n is the improper axis of rotation. Improper axis of rotation like this. After rotation, reflection. If you get the same molecule, then there to be improper axis of symmetry are present. Also, we know that if any molecule improper axis are present, so they are not improper axis are present, so there will be symmetry molecule. If there will be no improper axis are present, so there will be asymmetric molecule, and asymmetric molecule are generally the of the chiral molecule. So we could tell about that the symmetric molecule never be chiral, and find out that conformational stability. So from the conformational stability, we have to draw that diagram, and we have to remember that when there will be steric crowding, so there will be less stable conformation. When there will be no steric crowding, like that anti-conformation will be more stable one. And if there will be special case, like if the molecule are poised to hydrogen bonding or any gauge type of interaction are present in that molecule, then the configuration would be more stable. And in between, if we show that the steric crowding between methyl will be highest, but methyl hydrogen will be lowest, like that. And in between gauze and eclipse, the gauze will be more stable because that they are less apart, and gauze configuration happened in the 60 degree when the molecular 60 degree far apart from the torsional angle will be 60 degree there. Then we have to go that nomenclature of RS nomenclature. So first we have to find out that molecular chiral or not. So we have to find out the chiral center. Chiral center means that 4 different substituent are attached in a one center. So that will be our chiral. We have to given the priority wise number, and we have to find out that what is the position of the fourth priority. It will be below in the plane, then and if there will be clockwise direction rotation, then that will be R, and if this will be above the plane and the clockwise rotation, so this will be S comparison. Similarly, we can draw that this conformation, OH conformation to Fisher conformation, and in Fisher conformation that RS nomenclature are indifferent. So in Fisher conformation, So how the RS conference will look like. So we have to know that where the port parity is present is in the vertical plane or in the horizontal plane. If it is in the vertical plane, then that will be that highest priority. If the clockwise direction rotation will be R and anti-clockwise rotation will be S, and if the in the horizontal plane, then clockwise rotation will be S comparison and anti-clockwise rotation will be comparison. Now the symmetry element. Symmetry element we told about the improper axis of rotation. Already, if there will be improper axis present, so that molecular symmetry. If there will be no improper axis, so that will be disymmetric. In between disymmetric, so all disymmetric molecules are not chiral. In between disymmetric, there will be axis of rotation, and this molecule will be symmetric and chiral molecule. Molecule symmetry or disymmetry or asymmetry we have to find out.